All right, y'all. Today we're gonna be finishing up the notes from last time. What we're gonna be talking about here is if I give you the zeros and I give you a point, how can you generate the polynomial function? So I want to stress something here that when you see f of 0 equals 36, this actually means 0, 36. So this is giving you x value and a y value. Anytime you see f of 0 equals a number, that's actually all that it's saying. So what is this part saying? Well, the zeros are saying that x equals -2, x equals 2, and x equals 3. And if this is the case, then if I add 2 to both sides here, subtract 2 from both sides here, subtract 3 from both sides here, what I end up getting is x plus 2 equals 0, x minus 2 equals 0, and x minus 3 equals 0. And what I'm hoping that you've caught on to is the fact that all I'm doing is starting what we typically are at the end of the problem and working my way backwards, right? Usually you're given some polynomial function set equal to 0, you factor it in some way, and then you get the answer, right? Well, now I'm giving you the answer, and I'm asking you to generate the polynomial function. So I'm doing the same process from before, just in reverse. Okay, so what do I do now? Well, if x plus 2 equals 0, x minus 2 equals 0, and x minus 3 equals 0, then I can say that x plus 2 times quantity x minus 2 times quantity x minus 3 equals 0. And if you don't believe me, then think about it. If x plus 2 is 0, right, it doesn't matter what else I have. The product is going to be 0. And the same argument can be made for x minus 2 and x minus 3. The other tidbit here that we need to throw in is that there could technically be a number in front. We usually call this number a. Okay, so what I'm left with is a x plus 2 times x minus 2 times x minus 3, x minus 3. And we can say that this is equal to y, right? Just replacing 0 with y. And so this is our polynomial functions thus far. Now we're going to incorporate the fact that we know that if x is 0, y is 36. So if x is 0, y is 36. And what this allows me to do is calculate a, because now all I have, the single variable, everything has been replaced except for a. So we just solve. So 36 equals a. -2 times -3 is 6. 6 times 2 is 12. I just did it that way so that I wouldn't have to deal with negativity. I'm trying to be as positive as possible these days. Divide through by 12. That was a bad joke. There goes the positive. And a is 3. So what does that mean? That means my final answer is y equals 3 quantity x plus 2 times x minus 2 times x minus 3. Okay. And that's it. All right. Let's try another one. So here, let me track that up a little bit. So here we're given x equals -1, x equals 1, x equals 3, and then they're giving us the point 0, -6. Okay, so you can very easily, if you want to, we don't have to do this process every single time. We can jump right straight to here. So I'm going to do that for the interest of time here. I'm going to rewrite this as y equals a, x plus 1, x minus 1, and x minus 3. And you may be wondering to yourself, well, Mr. Anderson, what did you do exactly? Well, now that I understand the origin of where these come from, right, we just add 1 and set it equal to 0. When I add this over to this side, that means I have to change this sign, right? So that's what's going on here. That's why these signs are going to be changing, right, from positive to negative. But once you've done that, once you understand that, it's fairly straightforward. Then the next step, of course, is x is 0, y is -6, and we solve. And so we get negative 6 equals a times 3. Negative 1 times negative 3 is 3. Again, I'm trying to get rid of the negativity. And then we're going to divide through by 3. And a is negative 2. And so my equation is going to be, I'm just taking this right here and rewriting it with everything substituted in. Negative 2, x plus 1, x minus 1, x minus 3. Ran out of space there, apologize. Okay, so pretty straightforward, I think. I think once you get the groove of it, it's pretty straightforward. Let's do one more. Now, this is interesting because the back part, this is written a little different. So this is saying zeros are x minus 1 with a multiplicity of 1. So we're going to apply the same strategy. We're going to say y equals a. We're going to flip it, the sign, so if it's negative, it's positive here, so it's x plus 1. Now, if it says multiplicity of 1, then that's going to be raised to the first power. And then it says 3, so it's going to be x minus 3. Notice the sign change with a multiplicity of 2, so that's going to be squared. Now, the point is 215. So before, it's also interesting that before, the point was 0, which makes it super easy to solve. Now I'm giving you 2, which gives me maybe a little more work, but not really that much. Okay, so now we're just going to substitute what we know. Y is 15, x is 2, this is coming from here, everything else is the same. Okay, and then you clean it up. So this is going to be 15 equals a 3 negative 1 squared. This actually comes out to be really nice. Negative 1 squared is 1, 1 times 3 is 3, so we're left with 15 equals 3a, and a is 5. So we can put it all together now. So y equals 5, x plus 1 times x minus 3 squared. And that is the final answer. I think that's it. Yep, that's it. So hopefully this wasn't too bad, and I'll find y'all in the next math video.